All right, now we're going to look at our first major rule that sort of relates the derivative to the actual function. And so we're going to be talking about our first derivative rule here. And so what this says is that if f prime is positive, greater than 0, at a point x equals a, then our function f is increasing at that point. Or if f prime is negative, so less than 0, then our function is decreasing at that point. So really what this says, and we're going to be investigating this quite a bit, we're going to use this property quite a bit. What it says is if f prime is positive, if the derivative of f is positive, well then the original function f is increasing. And if f prime is negative, well then the original function f is decreasing. So this is a kind of a remarkable relationship between our function and our derivative f prime. And we're going to use this relationship. Being able to find that f prime is positive or negative turns out to be a bit easier than actually proving directly that a function is increasing or decreasing. But why is this plausible? Well, let's remember that when we talk about the derivative at x equals a, if that's positive, well, what the derivative actually is telling us, it's telling us the slope of the tangent line. So the slope of the tangent line is positive at x equals a. And what does it mean to be a positive tangent line or positive slope? It has to look something like that. So our graph is moving up. It's moving in an upward direction. So it has this increasing behavior. Now if f prime was negative, was less than 0, well again, f prime is the slope of the tangent line. So that means the slope of our tangent line is negative at x equals a. And what does it mean for a line to have negative slope? Well, it's moving downward like that. So it's decreasing. It has this decreasing trend. So this is going to be a nice relationship that we kind of come back to over and over again. If our derivative is positive, then the original function is increasing. If our derivative is negative, well then the original function is decreasing. Let's see an example where we use this. So let's sketch the graph of function f that has these 4 properties. So first property here, f of 3 is equal to 4. So what this is telling us is that there's a specific point on our graph. So this property here is telling us that point 3, 4 is on the graph of f. So this is just the x-coordinate here is 3, and the output here is our y value. So let's just plot. This kind of gives us a starting place for where to sketch our curve. So let's plot 3, 4. Okay. There's our point. All right, next, f prime of 3 is equal to 0. Well, that means we have a horizontal tangent line. The slope of our graph is 0. So we have a horizontal tangent line at x equals 3. So let's just draw in our horizontal tangent line. It's going to look something like that. And what that means is when we start sketching in our graph, it should kind of flatten out in some way. It should flatten out at x equals 3. All right. Well, what else do we know? Our derivative is positive when x is less than 3. So what that means, if our derivative is positive on the interval when x is less than 3, that means f is increasing when x is less than 3. And the other property here says that f prime is less than 0, so it's negative for x greater than 3. So that means our function is decreasing on the other side when x is greater than 3. So what's happening here is x equals 3 really seems to split up the behavior of our graph. On one side, on the left side here, when x is less than 3, and then what's happening directly at 3, and then when x is greater than 3. So when x is less than 3, our function is going to be increasing. It flattens out at x equals 3, which is why we drew the flattened tangent line there. And then when x is greater than 3, our function is going to be decreasing. So we just want to draw an example of a graph that fits these properties. So it has to go through this point. It has to flatten out when we hit x equals 3. And it has to be increasing on one side and decreasing on the other. So as an example, maybe something like this. So as we read from left to right, the graph is going up, it flattens out, goes through that point, and then it starts to decrease. Kind of fun. So we can use this information to help us sketch the graph of a function. All right. Well, it's not just the sign of f prime that we're interested in. What we're going to see next is the sign of f double prime.